What I want to look at here is what we can call offline Doppler, if you like. You've seen the moving source moving towards a receiver over here. Call it inline rather than offline, if you like. And you'll have drawn the graph where if the source was located here, and this is just a time graph and this was a frequency, then the observer is going to hear a higher frequency until suddenly it goes past him and he hears a lower frequency. Now remember that this isn't totally symmetrical. The amount the frequency goes up is not exactly the same as the amount it goes down. It's close. And we use that formula we derived already, which was that the new frequency is equal to the old frequency times VW over VW minus V source. Now, offline Doppler is where you've got your listener. That was a listener there. You've got your listener and he's offline. The source is still moving directly towards the listener, but he's now sort of standing back from it. Now, the point here is that Doppler only affects the wavelength if the source is moving in the direction in which the wave is traveling. Now the wave's obviously traveling in 2 dimensions, so it's moving out in lots of different directions. Doppler affects this direction. It doesn't affect this direction for the wave. The wave's obviously moving out this way as well. There's no velocity of the source in this direction. So how can Doppler affect that direction? It doesn't. It totally 100% the velocity of the source affects this direction of the wave, 100% not in that direction. That means in this direction, it's only the component of the velocity moving in this direction that is going to affect it. And since the velocity is this way, there is a component in this direction, and it's the old right-angle trick, and a component that is totally at 90 degrees to that direction. So we actually need just that component. This is Vs. So the component we would use would be Vs. If this is the angle here, theta, then the component we are going to use is going to be cos theta. So that at 90 degrees we get nothing. That's if that's the theta we're using. So when we actually do the graph, what we're going to get is the frequency is going to be, the amount of Doppler is going to be changing the whole time. And when it's very, very far away, it's going to be very close to this. So if we draw the graph again, like this, it starts off being nearly, if it's a long way away, nearly the same frequency as the original situation. Because at that point, the angle is very, very small and the cos is very close to 1. So as we look at it from this point of view, we'll get more of a graph that sort of does this sort of thing, if you like, and again, this one's coming close to being the same situation. So that's what I call offline Doppler.